try.
Perfect. So first of all, let's just say the format is going to be 45 minutes of the lecture and then the last 15 minutes of Q&A. Your representative will be in the chat trying to respond to questions as you type them in there and the best we can. And then we will try to take this transcript and respond to any questions that are not fielded in this format. But we want to welcome everyone, and we're going to turn it over to our presenter, who is Dr. Sarah Ellis, and she is working with Microbiome Labs. She's been with us, I think, about 6 months or so, but I'll let her introduce herself because she's got a terrific background as a naturopath. And take it away, Dr. Ellis.
Thank you so much, Tracy. Hi, everyone. I hope you can hear me well. My apologies for the technical issues. But my name is Dr. Sarah Ellis. I'm a physician, and I'm a clinical science liaison for Microbiome. And I'm so excited to be here today to share my talk today. Let me get my slides together. Wonderful. Okay, can you all see my slides?
We can. The audio is a little bit fading in and out. I don't know if it would help to maybe scoot a little closer to the screen. Maybe
yeah. How about now?
I think that's better. We'll see.
And I would maybe, Sarah, is just ask everyone to mute themselves while you're speaking until the Q&A, and I can see your slides.
Wonderful. Unfortunately, my mic has been kind of going in and out today, so I will do my best to speak up. But if you can't hear me, please let me know and I will repeat anything. Okay. So today we are going to be talking about shifting the paradigm of stool testing with BiomeFx. All right, so we're going to start with discussing the whole genome sequence difference with functional microbiome analysis. We'll be talking about 16S technology versus whole genome sequencing technology, why you should choose BiomeFx, report overview and insights, which patients will benefit from this test, how to leverage results to create protocols your patients will follow, and of course, we have a special offer for you at the end. Okay. Is Mike still going in and out, or are we good?
I think we're going to be okay.
Okay, great. All right, so BiomeFx is a functional microbiome analysis stool test. It provides valuable insight into the gut microbial ecosystem, and it is powered by whole genome sequencing through Cosmos ID. It is the most accurate testing on the market with 99.9% specificity and over 95% sensitivity. And every BiomeFx report comes with nutrition, lifestyle, and supplement recommendations. So what exactly is a functional microbiome analysis? Well, it paints a picture of the overall strength, resiliency, and health of the microbiome.
Yay.
Oh, hi. Can we make sure everyone is muted? That would be awesome. Okay. So in addition, it provides with insight into how the patient's diet is impacting its microbiome. And this valuable insight allows you, the practitioner, to direct treatment plans that restore balance to the microbiome and build strength and resiliency. So let's compare a functional microbiome analysis to traditional stool testing because they're very different tools. Traditional stool testing is used to diagnose a specific health condition, probing for specific markers, usually with 16S or culture, and it reports a list of all those markers. In the end, you can make a diagnosis, prescribe medications, use natural antimicrobials, and occasionally attempt to reseed with probiotics. But a functional microbiome analysis provides useful information about the overall strength and resiliency of the microbiome. It reports functions of these microbes, along with microbial mapping. And in addition, it provides broader reporting of who is in the gut with whole genome sequencing. We recommend diet, lifestyle, and supplement recommendations and protocols to help build and strengthen the resilience of your microbiome. So instead, we ask a question, who do we need to support by increasing or balancing? Whereas with traditional stool testing, the main question that we're asking is, who do we need to eliminate? So let's think about these as two different tools, as I mentioned before. Traditional stool tests can be a lot like security CCTV footage. It's grainy, it's kind of hard to see who exactly is there. Whereas a functional microbiome analysis is a lot like facial recognition software used with intelligence agencies around the globe. They have high-tech software to help you identify exactly who is present and what they're doing there. Now, I wanted to start with talking about the technology because most of you would like to know how does this differ from the stool test that we use now? Well, most stool tests use 16S or Amplicon technology. Now, all bacteria have the 16S RNA gene. Stool testing that is most common, they only look at about 2 targeted regions, whereas whole genome sequencing looks at all of the variable regions. Now, 16S is the most popular technology in the market, but it's also fairly old. It launched over 40 years ago, around the time of the invention of the cell phone. Now, think about how clunky and limited your first cell phone was compared to, oh, hi, I'm in the chat and the audio is still choppy. Let's see how I can fix that. I'm gonna do my best just to speak as loud as I can. My apologies for the choppy audio. So again, let's think about how clunky and limited your cell phone was 40 years ago compared to your iPhone 13 that you probably have today. So much has changed between cell phone technology back then and now, but stool testing has kind of remained the same. And so we want to make sure that we're using the most up-to-date and accurate technology when providing a service to our patients. So, as I mentioned, this gene shows 2 of the regions that 16S amplifies. However, whole genome sequencing will look at all 9. So there are some limitations. You only get a few pieces to the puzzle. So let's take a look at these images here. We can tell that this is a person. They have dark hair. We can see some facial hair here. So this could be a man, but we don't know a lot of details. Now 16S is similar. It only gives us a few pieces of the puzzle. It's not accurate beyond the genus level. There's only 14.7% specificity and 90% sensitivity at the species level. And it cannot identify viruses, fungi, or protists. Now let's put this into perspective. When we think of taxonomic ranks, we are going from kingdom to strain. And so if we look at humans, Homo sapiens, they belong to the kingdom Animalia, phylum Chordata, the Mammalia class, primate order, Hominidae family, and then the genus is Homo. Now, this genus actually contains both Homo sapiens, like ourselves, and an extinct species of the Homo genus that no longer exists. But if your test only goes down to the genus level, you will miss so much information. So at the species level, we are Homo sapiens. And when we get down to the specific strain, you get myself. With bacteria, it's very similar. We have bacteria. It can go down to the Bacteroides genus. And with BiomeFx, we can go down to the species and even the specific strain. So whole genome sequencing provides end-to-end sequencing of DNA, and it completes the puzzle. So previously we saw those little pieces, we weren't exactly sure who it was, and it turns out it is our co-founder, Kiran Krishnan. In addition, it accurately identifies species at the species and strain level. And it also identifies bacteria, viruses, fungi, and protists. So let's take a look at this visual of 16S versus shotgun or whole genome sequencing. Here on the right is whole genome sequencing. It includes the entire genome. As a refresher, the genome means that it's a complete set of genes or genetic material that's present in the organism. And so whole genome sequencing analyzes over 3 million base pairs, which is about 6,000 to 12,000 bacterial genes. Well, why is this important? Well, here on the left, 16S is only one gene. It's the 16S gene. And you can see here that the 16S gene is actually denoted with this red line on the whole genome infographic. And we've actually been able to pull it out here. So 16S only analyzes about 300 base pairs. And it actually takes about 2,000 to 400 base pairs to make one bacterial gene. So whole genome sequencing actually analyzes thousands of bacterial genes, whereas 16S really only analyzes 3/20ths of one single gene. That's 10,000 times more data through whole genome sequencing compared to 16S. All right. Now, our whole genome sequencing with Cosmos ID, we are so excited to be paired with Cosmos ID. It is the world's largest microbe database. And they have over 10 years of curating data. They have over 150,000 genomes and gene sequences. And they were huge parts of the Human Microbiome Project and the American Gut. And Cosmos ID family is composed of so many amazing organizations, including Johnson & Johnson, the CDC, Johns Hopkins, the FDA, USDA, and so many more. They do independent validation of their studies and of the accuracy of their research. They have the highest score in strain level microbial profiling, 64% higher score than their second best contender with whole genome sequencing. And they use machine learning based reduction to help reduce false positives while maintaining high sensitivity. So we've gotten all that tech talk out of there. So now let's talk about why you should choose. Well, the health of our microbiome impacts the overall health. It produces postbiotics, it performs a variety of functions that benefit our health, and it contributes to a well-functioning intestinal barrier. It has a low inflammatory load and builds a more resilient environment that's less likely to experience chronic disease. So on the left here is the picture of a healthy microbiome. A healthy microbiome has low levels of pathogens. It has a very diverse microbiome, a strong mucosal barrier, low mucosal inflammation, and strong, tight junctions along these enterocytes. Whereas a leaky gut over here on the right has a overabundance of mucus degrading and toxin producing pathogens as marked by these LPS hexagons here. That mucosal layer becomes inflamed and degraded. Then we begin to see damage to the enterocytes. So weak, tight junctions and inflamed intestinal cells. As LPS begins to pour through these intestinal cells, it activates the immune system, which then begins an inflammatory cascade, leading to release of inflammatory cytokines like IL-6 and TNF-alpha. And we also have dysbiosis risk factors. So we know that there are so many pieces to the puzzle that causes dysbiosis in our gut microbiome. That includes infection, excessive alcohol use, smoking, stress, medications, and even natural antimicrobials. In addition, lack of sleep, intense exercise, saturated fats, or the standard American diet, and even environmental toxins like glyphosate can increase your risk of developing dysbiosis in your microbiome. So why BiomeFx? Well, as you know, these risk factors impact the balance of microbes in our gut, and that leads to dysbiosis. Now, because different types of bacteria perform different functions, the postbiotics and functions being performed by your microbiome are also altered. And the only way to know how the microbiome has been impacted, and therefore knowing how to restore balance, is through a functional microbiome analysis. So our microbiome can impact a number of functions in our body. It can affect metabolic dysfunction or function, the development of autoimmunity, skin conditions, nervous system disorders, hormone balance, and even liver health and function. Now, as practitioners, particularly functional medicine practitioners, you know that it all begins with the gut. And so most patients have been exposed to a number of those dysbiosis factors that we talked about a couple slides ago. And so by using award-winning whole genome sequencing with unrivaled technology, sensitivity, and precision, BiomeFx is able to offer valuable insight into your patient's microbial ecosystem. It helps you provide a roadmap to restoring balance and building resiliency in the microbiome. And this influences their health systemically. So the microbiome or the BiomeFx advantage. Number one, accuracy using the whole genome sequencing technology. We measure over 20 functions of the microbes that are measured. The stool collection in return are very easy, and we provide dietary insights as well. So now let's look into the report. The report tells us who is in the gut, what they're doing there, if there's balance between these microbes, and how to restore balance, strength, and resiliency to the microbial ecology. So let's discuss the report section. All right, so we have overall diversity, stability, and resilience. Gut microbial composition, so telling us exactly who is there. We also discussed dysbiosis ratios, pathobiome, or the presence of pathogens in the microbiome, functional keystone species, short-chain fatty acid production, functional analysis, and vitamin biosynthesis. So let's discuss the report summary. This is important because it gives us an overall score. You get a score of 40. That's a combination or a sum of these indices mentioned here. It summarizes the details of the report. It provides an overview of the general health, strength, and resiliency of the microbiome. The at-a-glance, out-of-range pathogens, keystones, and functions are all here so you can see how your patient's microbiome has been impacted by different dysbiosis factors. Now here's a pro tip. It's important to pull up our report recommendations document as you go through the report. And that way you can create patient diet, supplement, and lifestyle protocols as you're going through the report. So let's talk about alpha and beta diversity. Alpha diversity measures the quantity of microbes present in the microbiome. So how many species in your patient's gut compared to the US healthy guts? Whereas beta diversity measures quality. So how are these species, how the species that have been identified, how they compare to the species in the healthy US gut? And then next we'll talk about the gut microbial composition. So not only do we tell you who's there, but we also look at what percentage of these different phylum are present in your gut. So we are showing you who is taking up the most real estate in your patient's microbiome versus who should be there. Now this page looks specifically at phylum. And as I mentioned earlier, it can be as specific as species and strain. So here we are looking at these 4 phyla, and ideally Bacteroidetes should take up most of the real estate, followed by Firmicutes and the others. Now, let's talk about Bacteroidetes. As I mentioned, it should take up the most real estate in the gut. But if we glance at it here, we can see that it doesn't. And so since we know that this patient is experiencing an imbalance in the ratio between Firmicutes and Bacteroidetes, we know that this patient is experiencing some dysbiosis. Now, Firmicutes, marked in red here, they contain the most Keystone species, but there are plenty of opportunistic groups residing in this phyla as well. That's why balance is very important. Now, Actinobacteria, marked by the small sliver of light blue here, this is where our Bifidobacterium species reside. And so we want to make sure that we're having plenty of this bacteria as well. Microbiome, as you can see here, this is where Akkermansia muciniphila lives. Akkermansia is one of our favorite keystone species that works really hard at rebuilding the mucin layer. And then lastly, we have Proteobacteria. Now, Proteobacteria is the most inflammatory phyla. It contains gram-negative bacteria that have quite a bit of LPS. Now, our goal is to have less than 2.7% of overall abundance. Because we know that everything exists in balance together, it's important to have a little bit of those, but keeping it in balance to avoid overabundance of the potentially pathogenic microbes. In addition, we measure these phyla as well. So the Uriarchaea, these are methane producers. As you may know, methane directly impacts gut motility. And so think constipation and SIBO. Synergicities, this section right here, often correlates with oral dysbiosis, gingivitis, and poor stomach acid. The Ascomycota phylum contains yeast, fungi, and mold. Spirochetes is where Borrelia and syphilis exist. And then Fusobacteria here down below, this is very inflammatory. It's a very inflammatory phylum. and is often associated with inflammatory bowel disease and colorectal cancer. We also look at dysbiosis ratios. So not only are we looking at the composition of each of these phyla, but we also look at how they exist with each other. So elevated ratios of this phyla point to dysbiosis, and it's associated with a range of health conditions. We compare firmicutes to Bacteroidetes, Proteobacteria to Actinobacteria, and Prevotella to Bacteroides. So let's look at one of these dysbiosis ratios, Proteobacteria to Actinobacteria. As I mentioned, Proteobacteria is the most pathogenic phylum. They are gram-negative bacteria and contain LPS. They also may secrete ammonia to help increase the alkalinity of the intestines and make it more hospitable for pathogenic bacteria to grow. Now, this phyla actually thrives on saturated fat and sugar, whereas Actinobacteria contain strong butyrate producers. And as you may know, butyrate is the primary fuel and energy source for our aqueous cells. And so certain bacteria in this phylum are associated with benefits like improved cognition, memory, and even social skills. Now, this phyla prefers to ferment fiber. Now, elevated ratio of Proteobacteria to Actinobacteria has been linked with intestinal permeability, inflammation, dysbiosis, and an increased risk of chronic disease. Now let's look at the pathobiome section. So first we start with measuring their pathogen control index. Then we'll identify any pathogenic species present. As you can see on this report, this patient has Clostridium difficile, E. coli, and Bacteroides fragilis. Now it's important to note that here you can see that it's actually elevated above the relative abundance upper limit, whereas these others are relatively low, and that's actually okay. Some of these bacteria, while pathogenic when overgrown, it's definitely a problem, but at very, very low levels, they do provide some benefit, like making some short-chain fatty acids, neurotransmitters, and also vitamins. Now, the pathogen species, we do look at bacteria, viruses, protists, and fungi. We also measure virulence factors as well. Now, keystone species. I think of keystone species as the sentinels of our microbiome. They set the tone for our gut by creating an environment that supports the growth of beneficial bacteria while crowding out pathogenic bacteria. Now, they have a very big effect on both the habitat and the status of other microbial components in the gut. They are short-chain fatty acid producers, and they create an environment, as I said, that's unfriendly to pathogens, but lets good bacteria thrive. And then we look at the functional analysis. So now that we know who is present, let's talk about what exactly these microbes are doing. So it mines the stool sample for genes that are known to contribute to the production of metabolically important functions. So they look at saccharolytic fermentation. How well do these microbes make short-chain fatty acids like butyrate, propionate, acetate, and lactate? It also looks at proteolytic fermentation. So how well is your microbiome breaking down proteins? And are they shifting a lot of that protein fermentation into potentially toxic byproducts like polyamines, phenols, ammonia, and hydrogen sulfide? We also look at hormones and neurotransmitters like GABA, glutathione, histamine, and the estrobolome. And we also look at vitamin biosynthesis. So can your microbiome make vitamins for you? The answer is yes, and we measure B vitamins as well as vitamin K2. So let's talk a little bit more about saccharolytic versus proteolytic fermentation. Essentially, our gut bacteria feeds on the food that we eat and gives off byproducts based on an activity. So saccharolytic fermentation, as I mentioned, is the fermentation of non-digestible carbohydrates. Their byproducts tend to be more helpful for short-chain fatty acids, whereas proteolytic fermentation is the fermentation of protein. And these byproducts tend to be more inflammatory, especially in high amounts. Now, this section can be very valuable for directing a patient's diet. So let's take a look at what the short-chain fatty acid production section looks like. We are measuring the genes that code for the production of butyrate, propionate, and acetate. Now with ammonia production, this is a result of proteolytic fermentation, which we mentioned earlier. Now elevated ammonia can be toxic to the gut, the liver, and the brain. And it occurs when there's an overgrowth of ammonia-producing bacteria with excessive dietary protein intake, especially glutamine. And in addition, it can also occur when the liver and kidney are a bit sluggish and struggling to help clear ammonia from the body. Now, hydrogen sulfide production is another byproduct of protein fermentation. And it occurs when sulfate-producing bacteria actually converts dietary sulfur and taurine into hydrogen sulfide. Now, it's a toxic compound that actually impairs intestinal detox pathways and can cause gas that smells like rotten eggs. Now, it is associated with high protein and low fiber diets. So again, this section is really great. It's a great starting point to help you learn how to direct your patient's diet to directly impact their microbiome. Methane producers. So as I mentioned earlier, methane slows the intestinal transit and actually affects gut motility. It is indirectly associated with a number of digestive issues. All right, so now I wanted to transition into talking about some of the most common BiomeFx patterns that we see. We see patterns that are associated with inflammation, constipation, so possibly SIBO or inflammatory or irritable bowel syndrome with constipation, a yeast overgrowth, and even digestive efficiency in the colon. So let's talk about SIBO and kind of what the patterns would look like with the BiomeFx test. Now, as a disclaimer, BiomeFx does not diagnose SIBO, but here are some common patterns. Methane production can be linked to the presence of SIBO. And so at the phylum level, you may see increased amounts of the Uriarchaea phylum. You may see an increased presence in the Methanobacter family. Methane production in the function section may be elevated. And you will often see that the patient is making decent amounts of acetate, but the butyrate levels are very low. Whereas on the other side, hydrogen sulfide production can also be associated with SIBO. And so you may see Delsulfovibrio in the family section or the fingerprint section of the report. You may also see Bilophilum sperthia. It's a pathogenic bacteria that commonly exists in the bile. And its primary function is to produce hydrogen sulfide, to reduce sulfates. And if you look in the function section, the hydrogen sulfide production would also be elevated. Now, irritable bowel syndrome with constipation. It is the most common functional GI disorder. And unfortunately, there's no lab test to help definitively diagnose it. But there are some microorganism panels, stool tests, that can provide valuable information. So Uri archaeata, as I mentioned before, this contains the methane-producing bacteria. You'll also see elevated methanobacter family levels, the presence of methanogens or methane in the function sections, and then you'll also see elevated amounts of fusobacteria as well. GABA production. GABA is a neurotransmitter that is produced by bacteria in our gut. It's known to have a calming effect on the brain and may even improve mood and sleep. Now, Bacillus subtilis, E. coli, Lactobacillus rhamnosus, and Bifidobacterium denture, along with several species of Bacteroides, can actually produce GABA in the gut. And so this is why the balance or dysbiosis ratios that we talked about earlier are so important, because these microbes all have very important roles in the microbiome. Then we also measure histamine production. So histamine is produced by certain microbes as a result of the breakdown of histidine, the amino acid histidine. Histamine is produced in the gut, and if overproduced, it can elicit an immune response, in other areas of the body, particularly if this patient already has some intestinal permeability issues. Then the histamine can cause immune responses throughout the body. It can enter the bloodstream, and then you'll have patients presenting with increased sensitivity, particularly to certain foods as well. And then we also measure the estrobolome. Now, the estrobolome is 60 genera of bacteria that can recycle or deconjugate estrogen. And it also activates estrogen to be recycled throughout the body. And these bacteria do this through producing an enzyme called beta-glucuronidase. Now, an elevated estrobolome can contribute to estrogen dominance, and this can lead to conditions such as fibroids and endometriosis. And then the last part of the section of the report is vitamin biosynthesis. As I mentioned earlier, microbiome does a really great job of making vitamins for us. Specifically, vitamin B9 and vitamin B12, cobalamin, gut-produced vitamins of, words are so hard right now, of folate and cobalamin, they actually contribute over 30% of our daily recommended intake. And so the amount of vitamins that our microbiome makes is very important for overall health. In fact, it actually highlights our symbiotic relationship between our cells and the millions of microbes in our body. Now, the measurement of the genes in this sample come from the bacteria. So this isn't looking at your patient stores, it's looking at your microbiome's genes to make these vitamins. So now that we've discussed all of the different sections of the report, how to use BiomeFx and also the technology, how do you know that your patient is a good candidate for BiomeFx? Well, patients who are the most serious about healing their leaky gut, patients for which more specific information would help you create personalized protocols to support their microbiome, and those who have been exposed to dysbiosis risk factors and have symptoms and health conditions that may be related to dysbiosis. So how can you leverage results to create protocols that your patient will follow? Well, first, let's talk about our report recommendations and interpretation guide. Our report recommendations guide can be found on biomefx.com. You can click and download it today. The interpretation guide walks you through the science of our report, the information on different phyla of bacteria, the different short chain fatty acids and their impact on overall health. And then secondly, you can book a complimentary clinical consultation with consultants, including myself, to go through your report, explain and highlight important pieces, and provide recommendations for your protocols. Each report, the first report that you run, you get a complimentary 60-minute consultation, and then follow-ups are 30 minutes. So let's walk through our report recommendations. They provide nutrition, lifestyle, and supplement recommendations for each marker of the test. In addition, like I said, you can find this on BiomeFx.com, the education tab, and report recommendations. So here's an example. Now we have a patient that has high C. diff, low Akkermansia, low GAP. So what does the report recommendation say to help improve this patient's dysbiosis? Well, for C. diff, if the relative abundance is high, the nutrition recommendations include avoiding processed sugars, incorporating prebiotic fibers and fermentable carbohydrates. The lifestyle section looks at really avoiding cigarette smoking, which is associated with C. diff infections, improving hygiene, washing your hands well. And then in the supplement section, it talks about the importance of Bacillus endospores, specifically Bacillus clausii, and the benefits of having immunoglobulins added to the supplement as well. Now, with regard to the Akkermansia section, if it is low, here are the nutrient and nutrition recommendations, our lifestyle recommendations, which for Akkermansia, you could consider intermittent fasting. And then our supplements include consuming cranberry polyphenols and prebiotic fibers, like these oligosaccharides, so present in our omega-3 prebiotic. And then for GABA, if your patient has low GABA, here are the nutritional benefits that you can do, lifestyle changes that can help increase GABA levels, and of course, supplement recommendations, including B6 vitamins, 5-HTP, and the oligosaccharides as mentioned previously. And so our personalized patient recommendations, overall, we have this for C. diff, Akkermansia, and GABA. As this translates to specific megaspore parts, the Bacillus clausii can be found in Stool or a megaspore. The IgG can be found in Omega IgG 2000. For Akkermansia, our cranberry phenols can be found in Megamune, and then the prebiotic fibers are found in Omega-3. And then we also have other recommendations that even include mushroom powders as well. All right. So how does BiomeFx compare to tests like GI-MAP and GI-FX? Well, GI-MAP and GI-FX, they're not diagnostic, but the paradigm behind using this test is comparable to traditional stool tests. So you're looking for a specific marker with the question, who do I need to get rid of? Who should I eradicate? And these tests usually result in antimicrobials. And while sometimes this is necessary, it can result in overall harm to the microbiome. This test, they have no or very limited functional microbiome analysis section in order to report the functions of different microbes and their impact on the microbiome. Whereas BiomeFx, actually looks at the overall strength and resiliency of your microbiome. It answers the question, how can I support and rebuild the microbiome with diet, lifestyle, and supplement protocols? The functional analysis also includes genes from all of the microbes found in the patient's sample, rather than just looking for specific ones. And the technology really doesn't quite compare. GI map uses 16S and 23S technology. GIFX uses 16S, mass spec, and microscopy, but BiomeFx uses whole genome sequencing. And of course, the most common question that we get about our test is, where are the intestinal markers? Now, we do understand the value of secretory IgA, fecal calprotectin. These are very common markers to be measured. And they do provide additional information to the full clinical picture. But essentially, they already confirm what you know. So it tells you that you already know that your patient has inflammation in the gastrointestinal tract. And you already know that they're likely dealing with some sort of chronic infection. Whereas BiomeFx helps you highlight the root cause mechanisms and microorganisms that's associated with the changes in secretory IgA and fecal calprotectin. And I always love sharing these next two slides because it talks about the effect that BiomeFx has had on clinicians and how it's helped them improve their patients' health. I'll only read the first paragraph for time, but essentially this client has been using other companies for a while, and this was the first time that they tried BiomeFx. And it wasn't long before she saw why so many of her colleagues were switching to them. And the comprehensive test covered a broad scope of microbes and was super easy to decipher results once they came back from the lab. So in summary, BiomeFx is a functional microbiome analysis that analyzes who is in the gut, what they're doing there, and provides next step treatment guidance to restore balance to the gut, and therefore overall improving the health, strength, and resiliency of the gut microbiome. Today, we have a very special offer for you all who are joining us today. This coupon code will give you 15% off of your BiomeFx test. I'll leave this up here now so you can jot it down, but thank you so much for your time. I apologize for the audio issues, and now I'm going to open it up for questions.
Thank you, Dr. Ellis. I think it helped having your picture because in some ways, the expression on your face kind of helped us interpret what you were saying. So thank you for that.
Of course.
So do we have any practitioners that had specific questions, either about a test that they have done themselves or just an observation about tests they've done for their practitioners? I mean, for their clients or patients.
I do have one in the Q&A from Megan McNeil. Thank you for joining us today. What is the minimum age recommended to run a BiomeFx test? I have seen tests on a child as young as 5. So really, it's just about getting the data and determining how it fits that specific pediatric patient. Hi, Jacqueline. Thanks for joining us. How long does it take to get results? It's my understanding that it may take about 2 weeks, 2 to 3 weeks to get it from after you send it off to get the results back. Tracy, if that's incorrect, can you?
No, that is correct.
Okay.
The time clock starts when it lands at the lab, and it should be 14 days.
Great. Hi, anonymous attendee. Is this test available in India? That is a great question that I'm actually going to have to ask our operations department. If you'd like for us to follow up, you can let us know who your rep is, and then we can make sure we get that information to you. And then, hi, Kathy. What is the time frame to run a test post antibiotic use? You could run this test. You don't have to stop taking any supplements or anything while you're doing the BiomeFx test. So you could run it a day after stopping antibiotics while they're currently on them. So there is no time. And hi, Megan. When you note the correlation of saturated fat intake and these markers on the test, is there any difference on type of saturated fat, like coconut oil versus eggs? Very, very good question. We have actually found that there really isn't much of a difference, even though coconut oil is a very good saturated fat. Gram-negative bacteria still use it to capsulate the LPS. So generally, we haven't really seen much of a difference in the impact of coconut oil versus other saturated fat on the microbiome. Of course, it's always better than lard. So when in doubt, always choose coconut oil. Hi, Phylum, welcome. Thanks for joining us. Why does butyrate diminish and how do we increase it? I'm not a fan of butyrate. We found that the best way to improve butyrate is to increase those keystone species, specifically Faecalibacterium prosnitz. I know it's a mouthful, but that is our primary butyrate producer. And our bacillus spores helps facilitate the growth of those keystone species. So using Megaspore and other bacillus spore products that we have will help increase butyrate. And we find that butyrate diminishes when our gut diversity diminishes as well, because we're having less microbes that can make the butyrate. And time of day to collect the sample, you can collect the sample at any time. Hi, Tina. If the patient has serious pathogens, would BiomeFx detect them? What are the usual recommendations? Yes, it will detect serious pathogens. The recommendations, they vary. You can see all of the different recommendations in our report recommendations guide. It walks you through each individual pathogen. And yes, the patient can take a PPI prior to taking the test. Hi, Phil, thanks for joining us. Is there any age that we should not use the microbiome gut health products with? Okay, safety-wise, our age for capsules to avoid a choking hazard is 8 and up. I believe our powdered products are suggested use is 5 and up, but we do have anecdotal evidence to show that even a very small amount of Megaspore, like a quarter of a capsule, would be beneficial for young children, more like toddlers, and we're always very conservative with infants, of course. And do we have any other questions? All right. If you have any other questions, just let us know. Do we have to start low and go slow with IgG 2000? I encourage to start slow, particularly with patients who are struggling with constipation, because mega IgG 2000 can increase constipation, but that can be resolved with improved hydration. So generally, you can go with the full dose of IgG 2000. And then what are the oils you are recommending? I'm not sure of that question. The only oil I remember talking about was coconut oil with regards to saturated. Since the microbiome is not mature until 2.5 to 3, it would still be dynamically evolving. That's right, Tracy. Exactly. All right. Any other questions? Oh, I see we have one more.
On behalf of all of us, Dr. Ellis, we really appreciate your expertise, and we are hoping to have another lecture next month on the immune system, and then we're targeting women's health, the vaginal test, menopause, and hormone replacement topics in December. So if you want to all join us back then, we appreciate your participation, and please get with your rep for any further questions, and let us know if you like this format. Thank you, everyone.
Thank you, everyone. Bye-bye.